very pleased to welcome Professor Alan Winfield back to be a speaker. And he's spoken to us a number of times before. His talks have always been excellent, and we're really pleased to have him back here to talk about robot accident investigation. The area of AI and ethics is particularly interesting and a hot topic at the moment. So I hope that you'll all welcome Alan and listen to his talk as intently as I intend to. So Alan, I'll hand over to you.
Hello, thank you very much indeed for that welcome, and it's great to be here. And as Brian said, this is not my first meeting with you all, so I'm delighted to be back again. Of course, it's a shame that we're not, sharing the same physical space, but that is what it is. So I'm just going to share my screen and start my PowerPoint. Oh, in fact, that is, I need to go back to the beginning. Okay, so I'll share my screen again. There we go. So slideshow, play from start. There we go. So I hope everybody can see that okay, see the slides okay. So as Brian said, I'm going to talk to you about work that I'm doing, in fact, with the University of Oxford on robot accident investigation, and the work is within the purview of this project called Robotics, and you can see the logo on the title screen there. So Robotics is a project based on responsible robotics, and I'll explain what that is. But essentially, we believe that robot accident investigation is an instance, if you like, of responsible robotics. So I'm going to start with a kind of a scenario. So imagine that your elderly mother or grandmother has an assisted living robot. This, in fact, our scenario is based around a fictional scene, and the lady is called Rose, and the robot would, for instance, remind Rose to take her medicine, would remind her to drink water, when it's time to have a glass of water, and maybe even bring the water, as this robot is doing, and other kinds of functions, keeping in touch with family and so on. But here's the scene I want you to imagine. Imagine that a neighbor, one of Rose's neighbors, calls round, and there's no answer to the door. And she looks through the window and sees Rose lying on the floor. She calls a paramedic, and they get into the house, and Rose is injured. There appears to be bruising to her legs, and the robot is milling around aimlessly. So in this fictional scenario, we have to ask ourselves, well, how did the accident happen? Did the robot cause the accident? Or maybe it didn't cause the accident. Maybe it made matters worse. I mean, at the very least, it should have noticed that Rose was on the floor and immobile. Now, this is a fictional scenario, but in fact, it could happen today. So robots like these exist. They're starting to be used in elder care homes and in hospitals. It's unlikely that private individuals would have them yet because they're pretty expensive. But here's the thing. If this accident were to happen today, it would be extremely difficult indeed to discover exactly what went wrong. And the reason that we would find it hard to discover what went wrong is that right now there are no processes. In fact, there are no technologies or processes for robot accident investigation. Now, we think that's a deficit. We think that's a problem. So let me now then introduce the project. So why are we interested in accidents? Well, accidents happen. It's very difficult to find data on accidents in relation to robots, but in fact, the US Department of Labor does have a web page where they list industrial robot accidents. And I've just taken a snapshot of part of this web page. And this is, it was a snapshot I took a year or so ago. And you can see that there are descriptions of events, and these are all industrial accidents. And if there's an X in this column, that means it was a fatal accident. And there's a summary, so you can click on a link and go and find out about the accident. So the point is that industrial accidents have to be reported. The same is true in the UK. The Health and Safety Executive would require industrial accidents to be reported. But as far as I know, the HSE doesn't actually have a website with robot accidents, or at least a site where you can type the keyword robot and get a list just of robot accidents. But of course, as I say, accidents happen, and they're happening in robotics. Here is an accident you may well recall. It was the first of several, unfortunately, fatal accidents involving the Tesla and implicating its autopilot function. So this was this of course made headline news around the world. Sadly, the driver of the car, of course, he wasn't driving at the time of the accident. Joshua Brown was killed in this accident, and it was thoroughly investigated by the US National Transport Safety Board, the NTSB, and I've just extracted a diagram from their report that just shows a picture of the car traveling down the road from the left, and this is a large trailer that crosses in front of the Tesla. The Tesla autopilot failed to perceive, if you like, the white trailer, probably because it was white and it was a cloudy day, so there was nothing to see. There was no, as it were, colored object, and as a consequence, the car. It's clear that Joshua Brown was not paying attention. The car then drove under the trailer, ripping off the roof of the car, and you can see the car was traveling so fast that it came off the road and didn't come to a stop for quite a distance in the field at the side of the highway. So a really shocking accident. Now, the accident was investigated because the technology and the processes do exist for motor vehicle accidents. And that's true, of course, of aviation and railways. But here is a social robot, a robot that interacts with people. And normally we have no idea when such robots are involved in any kind of accident or incident. We only happen to know about this because it was reported in the national news. This is a security robot and there was a collision with a child. The child, I believe, was not seriously injured, but nevertheless there was an accident. My guess is that that accident was not investigated. And really the focus of the project, our Robotics project, is social robots. And let me tell you about the project. So it's a 5-year project funded by EPSRC, the Engineering Physical Sciences Research Council. And what we're doing within the project, within a broader framework of responsible robotics, is we're interested in both the technology and the processes of robot accident investigation. But let me start with responsible robotics. What do I mean by that? Well, we define responsible robotics as the application of responsible innovation in the design, manufacture, operation, repair, and end-of-life recycling of robots that seeks the most benefit to society and the least harm to the environment. And this little Venn diagram on the bottom right, we're really positioning responsible robotics as a subset of responsible innovation. And I'm sure many of you are aware that there are well-known processes for responsible innovation. In fact, when anybody is in receipt of an EPSRC or a UK RI research grant, they are obliged to sign up, if you like, to the principles of responsible innovation. And we believe that responsible robotics is a kind of superset of robot ethics. So this kind of puts robot ethics and responsible robotics in the context of the more general practice and well-established practice of responsible innovation. Of course, this least harm to the environment is a nod to climate change and sustainability. And just then as a side, I'm very interested in the question of how robots can be sustainable. And as part of my work with the British Standards Institute, we're now starting to write a new standard. I think it'll be the world's first on sustainable robots. So that's responsible robotics. Now, I mentioned that accident investigation needs technology as well as process. And around 4 years ago, Marina Jurotka, my partner in the project, and I published a paper called The Case for an Ethical Black Box. And our proposition is very simple indeed. It is that all robots, and in fact, by extension, AIs, should, as standard, and I would prefer by law, be fitted with the robot equivalent of an aircraft flight data recorder. It's a very simple idea. So why do we need to do this? Well, because without such a device, you've really got no chance of being able to investigate robot accidents. That's what it boils down to. Unless you have a log, a data log, a secure log, time-stamped of what the robot was doing in the moments leading up to the accident, then how on earth can you find out what was going wrong and put it right? So it's a very simple case. Now, we're working on the technology of the ethical black box, and this is essentially a kind of block diagram showing you how it relates to the robot architecture, which typically has sensors, an embedded artificial intelligence, and actuators. In other words, the motors and actuation of the robot. And the ethical black box needs to have a one-way connection. In other words, data flows from the sensors, from the AI and the actuators. And of course, you need to be able to access the data in the ethical black box. And typically you'd want to store compressed or sampled sensor data periodically, actuator demands, high-level goals, alerts, and decisions, ideally with the reasons for those decisions. And of course, you need to be able to connect with this device to access the EBB data. You may be wondering why we call it an ethical black box. Well, simply because we think it would be irresponsible, i.e. unethical, not to have one, not to equip your robot with one of those. So that's why we call it an EBB, and it, the terminology is kind of stuck now. So, but it's important, of course, to understand, and I'm sure you do, that accident investigation is primarily a human process. It's a process by which we put together evidence from a black box, a flight data recorder in the case of air accidents, together with witness testimony, forensic evidence, and of course an examination of the vehicle that actually was involved in the accident. So it's a human process primarily, but the technology is important. This flight data recorder is important. And what we're doing in the project, and of course we're behind because we've had a year and a half of not being in the lab, not being in the universities. So we haven't actually started doing these, but it was our intention to start more than a year ago. Essentially, we're setting up and running 3 staged, that is mock accident scenarios in assisted living robots, educational toy robots with children, and driverless cars. And for each of these, we're looking for human volunteers. So these will be, there'll be real robots as it were in a scenario. It's a staged scenario, clearly. And of course, nobody's going to be hurt, but the human volunteers we need are as subjects of the accident, the people to whom the accident happens, witnesses, bystanders who've seen what went on, and also members of the accident investigation team. So these human volunteers would be part of these scenarios. Of course, the subjects of the accident would be briefed about what's really going on, and they are in a sense actors. The witnesses and the members of the accident investigation team, the volunteers, would not be briefed. So they would, as it were, simply report what they saw, what they witnessed, or what they find from the evidence. So what is the purpose of accident investigation? Well, this is general. This is not just robot accidents, but essentially the fundamental purpose of accident investigation is learning. And it's organized around 3 key questions. Firstly, what actually happened? Secondly, why did those things happen? And what does that reveal about weaknesses in the design and operation of the system? And how can the system be improved to prevent similar things happening in future? So it's what, why, and how. And really the aim of any accident investigation is to come up with practical, achievable, and targeted recommendations for making safety improvements. Of course, air accident investigation, I've mentioned several times already, is the gold standard of accident investigation. And the air accident investigation community have this wonderful motto: anybody's accident is everybody's accident. And what that means is that the data, the findings of an accident investigation should be shared, should be made available to everybody in that industry. And in fact, one of the reasons that aviation, commercial aviation, has such an amazing safety record is because of a very long-standing now culture of data sharing between manufacturers and between accident investigation teams. So the point is that there may be a problem with a particular accident, and of course I should include near misses, because near misses in both aviation and railways are are investigated just as assiduously as actual accidents that caused harm. So near misses are a very important thing in improving safety, but this culture of data sharing is really very significant to the reason that our commercial airline air transport is so safe, has such a great safety record. Something clearly that needs to be emulated in other spheres, and we argue in robotics. So why social robots? Why do social robots need robot accident investigation? Well, it's true that robot accidents are relatively rare, but we think that second wave, these are social robots, the scope for second wave robot accidents is much greater than first wave industrial robots. And the reason for that, of course, is that, as you know, industrial robots typically operate behind safety cages. In contrast, dramatic contrast, social robots are designed to be among us, up close and personal, literally in the case of the scenario that I showed you at the beginning. Of course, also industrial robots operate in an environment optimized for them and not humans. Social robots do not. Social robots have to make do with human environments. And thirdly, the scope of harms that can arise from social robots is much greater because it includes ethical harms. In other words, the harm might not be physical, it might be psychological, it might be environmental, it might be societal. There are a whole range of harms which are important and serious, which are not, which are in a sense a superset of physical harms, which of course we fundamentally do need to be concerned with. So social robots really have a very broad scope of possible accidents. And in fact, in the three scenarios, the second scenario, the one involving robot toys, we're interested in investigating psychological harms that might arise from robot toys as opposed to physical harms. So let's now turn to Rose's fall, the scenario that I showed you at the very beginning. So what I'm now describing to you is, as it were, a fictional account of the accident generated by a robot accident investigation team. Now, one of the reasons that this is all fictional, of course, is because of the pandemic. So, when we wrote up this paper, which you can find online, it's an open access paper describing the process of robot accident investigation. We had hoped to be able to write up alongside, as it were, the process, the findings of the first mock accident investigation. We couldn't do that, so we had to make it up. So this is all completely fabricated, as it were, findings of the investigation. So here is the witness testimony following Rose's fall. So the neighbor finds Rose on the floor in the kitchen and calls for a paramedic. The paramedic attends to Rose, but also reports seeing the robot in the living room, not the kitchen. The paramedic also notices that Rose is not wearing her fall bracelet. Now, anyone who has an elderly mother like I do will know that fall bracelets or panic alarm bracelets are really important devices and lifesavers for many elderly people. The cleaner reports that she cleaned as usual, including disinfecting the robot as instructed. That's interesting. Rose thankfully recovers, but after recovering, she reports that she wanted something from a kitchen cupboard, climbed onto a chair to reach it and fell. Rose also remembers calling out for help. So what do we make of this? Well, of course, we need to look at the data from the ethical black box. And again, this is fabricated, but I believe it's plausible. So this is an annotated timeline from the ethical black box. So the blue arrow in the middle is hours, and 0 hours is when the accident is, when the paramedic arrives, if you like. And the fall, we don't know exactly when the fall happened, but it's going to be in the region of half an hour between, up to an hour before the discovery of the accident. Now, these red boxes at the top are interactions between the robot and Rose. So you can see that here the robot is waiting for instructions. At about 3.5 hours before the accident, the robot reminds Rose to drink water. And then, oddly, at a little bit later, the robot tells Rose that it is lost connection. Lost connection, in other words, with the Wi-Fi. And the same thing happens again, not long before we believe the accident actually happened. The robot tells Rose it has lost connection. Down underneath the timeline, in the blue boxes, we have where the robot was. So it leaves its charging station 4.5 hours roughly before the accident, moves to the living room, moves to the kitchen, living room, and the robot is searching for Rose at the time that the accident is discovered. And then in these green boxes at the bottom, you have the connection status. So the robot loses connection with the home hub there, and it's reported to Rose. And again, then it regains the connection, but it loses it again shortly before reporting to Rose that it's lost connection. So there's some important information in the EBB. Now, we propose in the paper that all of this needs to be put together to construct a why because graph. And we think why because analysis is precisely the right approach to, as it were, graphically construct a timeline of events for the accident. So leading up to the accident. Now, the first thing to notice in this graph, and I should say that time moves from the bottom to the top, is that we actually have 2 accidents. So it's realized, of course, that essentially there's Rose's fall. We want to know why Rose fell from the chair, but we also want to know why the robot failed to raise the alarm. And these boxes all have different meanings. So the square box is events, in other words, a change of state in the world. The box with kind of cut off corners are processes, which are sequence of events that happened. The triangular edge boxes are states. In other words, they're states of the world or the system that remain true over the whole of the accident. And finally, the round boxes are called unevents. So they're called unevents because they're things that should have happened that didn't. And it's an important distinction between events and unevents. So if we look, we can see that actually the direct cause of Rose's accident is that she tried to reach a high cupboard, she climbed on a chair and slipped off the chair. So that is, there's a clear chain of cause and effect from the event, the processes, and the accident of Rose's fall. But Rose also called out for help. But the robot is too far from Rose to hear her, it seems. And even if the robot was close enough, its fall detection system was not triggered. And even if it had have been triggered, it wouldn't have helped anyway, because the wireless connection to the home hub is disconnected, and that is clearly a critical failure point. So actually, we discovered there are 4 possible routes to accident 2. This one is about the microphone and Rose calling out for help. This one is about disinfecting the robot, because we believe that the cleaner may well have scrubbed the sensors on the robot and caused them to malfunction. Rose is not wearing her fall bracelet, but even if she was, it wouldn't have helped, because the home hub is disconnected because of the wireless failure. So there are multiple causes of accident 2. The robot fails to raise the alarm. So this process is incredibly helpful, and it really allows us to come up with a number of key findings and remedies. So as I mentioned already several times, there are 2 accidents, and the recommendations are, well, actually, I should have written recommendation 1, do not report the connection failure to Rose, to the user of the robot. It's a meaningless thing to do. How on earth would Rose know what to do about it if the robot says, I've lost connection? Essentially, the robot needs to be equipped with a backup communication system in case the Wi-Fi fails. In other words, it ought to have a mobile phone connection, in other words, a PSTN connection, perfectly simple to install, that would send an emergency call directly to a call center if the fall bracelet is triggered, just as does happen with panic alarms, that you get an automatic call via the telephone network. The robot's microphones need to have improved sensitivity. We should add a new function to the robot so it reminds Rose to put on her fall bracelet every day. And of course, we should also advise the cleaner not to use disinfectants on the robot sensors. So, and what these findings and remedies illustrate is that the remedies, recommendations, are a combination of technical fixes, improvements, if you like, to the system, to the technology, but also operational improvements, such as the one about the cleaner not using disinfectants. And of course, having a backup, someone to receive the backup call. That's an equally important operational finding. So that really brings me to the end of this short presentation. Obviously, I'm very happy to answer questions, but before I do, I need to thank the rest of the team, in particular the principal investigator, Professor Marina Girotka, I'm sure many of you know, Helena Webb, and my colleague in the Bristol Robotics Lab, Dr. Anouk Van Maris. We also, in fact, have an advisor in the project, Professor Carl McRae, at the University of Nottingham. Carl is an expert and authority on accident investigation. So it's really wonderful to have that kind of expertise available to us. And as I mentioned, you can find both of the papers, the case for an ethical black box and the paper that describes the work, obviously in much more detail, that was published, in fact, early this year. And you can find that paper on Archive, a preprint, or you can, email me if you can't find it. So I'm going to stop sharing the screen, and ask if there are any questions.
Thank you very much, Alan. That was excellent. I suppose I shouldn't be surprised, but I was surprised at how complicated the process is. And there's obviously a lot to learn from historical accident investigation. While we're waiting for people to put questions into the chat, maybe I can just start the ball rolling, as it were. This may be too simplistic an approach, but if you go back to the sort of Asimov's 3 laws of robotics, are they useful in this sort of context or not?
Not really, no. I think when I gave a previous talk, I think I probably spoke about ethical robots. So I'm certainly interested in how we might build ethical robots, but here we're concerned not with robots that themselves behave ethically, but the robots that are designed and operated ethically. So robot ethics is primarily concerned with how human designers, operators, manufacturers, users, well, users, of course, don't have to necessarily behave ethically. We hope they do, but the burden, of course, of responsibility must lie with the designers, manufacturers, and operators of the robots. So yes, the robot doesn't have to itself be ethical. It has to be ethically designed, and I've been part of an initiative by the IEEE Standards Association called the Global Initiative on the Ethics of Intelligent and Autonomous Systems, and we are interested in how what are the methods for doing ethically aligned design. In other words, make sure that values are designed into that, which is different to ethics. You know, ethically aligned design is not the same as designing a robot to be explicitly ethical. Excuse me. So I hope that answers the question.
Yeah. But I see we've got a couple of questions coming in now. The first one was from Mario and said, how are you going to address the security and privacy when sharing the data of the ethical black box? And how do you address it?
Well, that's a really good question, and it's something we do worry about. But the first thing I should say is that in conventional accident investigation, in aviation, transport, and railways and so on, the data in the data loggers, they're called event data recorders in road transport, for instance. Access to that data is privileged access, and it's confidential. So the point is that you'd expect the accident investigators, even for social robots, to not share the data. In other words, the details of the data with anyone outside the as it were, the closed group of the accident investigation team. So that, I mean, that's an important thing to understand. And of course, accident investigators do have strong professional codes of conduct and so on. So they have to be regarded as trusted with that data. Nevertheless, I think it is important that the user of the robot, in other words, Rose or Rose's family, should have the option of opting to have some personal data not recorded. And the way that we would approach that is that we would recommend that manufacturers explain to customers what data can be collected, the value of collecting that data. In other words, if an elderly person opts out of, for instance, recording audio of the conversations, then it may make it harder for an accident to be investigated. So that should all be explained, so that the owner user, if you like, of the robot should have the option of opting out. I mean, I'm not sure that should be true for all robots. So, for instance, I don't think you should have an opt-out clause for event data recorders in vehicles. You don't at present, for those vehicles that do fit them, and I think that's reasonable, because the point is that there are third parties always, or typically, involved in accidents with vehicles. So I hope that answers the question. In fact, I should also tell you that we have a new member of the team in Robotics who is taking a law degree. So and she's a part of the team now, in order to be able to provide us with if you like, expert opinion on data rights and privacy and such like. So I hope we've got that covered, and I hope that answer was
yes. Mario said excellent, thank you.
Thank you.
We have another question from Helena.
Yeah.
She says, I presume a risk assessment is to be done to see if the environment is safe for the robot too, e.g. steps or pets or the like.
I'm glad you've mentioned risk assessment, because we've written papers recently on ethical risk assessment for robots. And in fact, again, as part of my work with the British Standards Institute, I was one of the co-authors of what we believe is the world's first ethical standard for robotics. It's BS 8611. It was published in 2016, so quite a long time ago now. And the title is, I think, guidelines on the ethical design of robots and robot systems. And what it is primarily is a method for doing ethical risk assessment of robots. Now, your question really is related to that, and a risk assessment in the environment is equally important. I think that's a very important thing to do. We typically, well, in research labs such as the Bristol Robotics Lab, where I work, we have to do risk assessments for everything. Every bit of equipment is assessed, risk assessed, and those risk assessments have to be acted upon and filed away and such like. So risk assessment should be done, and that, I would assume, would be the responsibility of both the manufacturer, and it's a shared responsibility, the manufacturer, the operator, and the installer of the robot. So the short answer is yes. I think risk assessment is an extremely important, and in fact, I think we make the point in the paper that risk assessment, if you like, is a way of trying to preempt and minimize the likelihood of accidents. Of course, no risk assessment can anticipate everything, so that's why you need accident investigation. They're kind of two sides of the same coin.
Yeah. Right. There's a question here from Matthew, who says, have you thought about how people might react to an ethical big brother, where a robot records everything that happens in a house, particularly when video is recorded? Is that something that we should be worried about? Yeah,
short answer, yes. And it's kind of happening already. So some of the robot toys, the smart robot toys that very popular right now, are connected devices. So in other words, many of them have advanced functionality like speech recognition, and some of them have facial recognition. Now, typically the heavy lifting, if you like, of the computation is done in the cloud, not locally, because these are very simple, as it were. Actually, they're very sophisticated, but relatively simple devices computationally in the local, in the actual toy. So there is an example of data which is shared, and those need to really be very clear with parents of children what data is being shared, how long it's being shared, stored, the right to delete it as often as you wish, or even delete it immediately, and so on. Another part of my answer to the question there from Matthew is that we would argue that the data stored in an ethical black box in a robot doesn't have to go anywhere. In other words, it doesn't have to go to the cloud. Why should it? So it's stored locally, and therefore it isn't shared, as it were. It doesn't go outside the house, and it's only. And the other thing about, of course, about ethical black boxes, just like flight data recorders, is that they will delete old data. So normally what you have is storage only of the most recent number of hours. I mean, a flight data recorder, an aircraft flight data recorder, typically record the most recent 17 hours. Don't know why it's not 17, not 20 or 15, but it's 17. And so any data that's older than 17 hours is lost. Now, interestingly, event data recorders in cars, the kind that are used in, for instance, emergency vehicles, typically only store the most recent 30 seconds of data. So there's a huge difference there. But the point is that number one, the data is only stored locally, and number two, it's not stored forever. And I think those are good principles to avoid the kind of big brother scenario.
Yes. We've got another question from Jeff here, who says, can you tell us a bit about the state of legislation in terms of apportioning blame in the event of a robot accident?
Yeah, that's a really tough question, and I'm not a lawyer, and I'm not sure I could properly answer that. But I think it's important to remember, of course, that that robots are products, and they're covered by plenty of existing law. So product safety law, they're covered by privacy laws, they're covered by even human rights. So there's a lot of law that exists, and robots, and there's nothing special about robots that means that they're outside all of that law. And interestingly, there was a European Union project called RoboLaw several years ago. I know the people who worked on that project, and their finding was that there doesn't need to be a kind of lex robotica, a new law written for robots, because really most situations are covered by existing law. Now, that doesn't answer your question, but I would argue that apportioning blame is probably no different. In other words, the problem of how to apportion blame is probably no different in a robot accident as it is in any industrial or office equipment accident, or even a road traffic accident. I.e., it's not easy. And that gives me another opportunity to mention work that I've been doing with the IEEE. I mentioned that the initiative earlier, but for the last 5 years, it feels like forever, but it's 5 years, I've been leading a new standard effort, and we've written, it's now gone up to the big committee hopefully for approval, a new standard on transparency. and this is the standard is called P7001 on transparency of autonomous systems. And of course, transparency is extremely important, because without transparency, you can't have accountability. In other words, you need to know what went wrong, and attached to that, well, who was responsible for the system that went wrong? Was it the prime manufacturer, or was it a subsystem that failed? And there are those kind of issues which are thorny in any accident investigation, where there is apportionment of blame. Actually, I should mention already, also, sorry, Jeff, that blame is something which is excluded by law from air accident investigations. So it's interesting that the findings of air accident investigations cannot be used in a court of law. That's not, that isn't to say that people, manufacturers can't be fined. Of course they can, but the point is that it was decided, quite early, I believe, in the history of air accident investigation, that if the primary purpose of accident investigation was to discover who's at fault, rather than what equipment or systems or operations were at fault, then it was believed, and I think correctly, that manufacturers would be much more reticent about being open with the findings from accident investigators, and they'd probably object to accident investigation teams appointed by a regulator coming in and doing the accident investigation. So this kind of no blame culture doesn't mean that there are no sanctions. Clearly, there are plenty of sanctions. When I got to look at the Boeing 737 MAX tragic accidents, there were plenty of sanctions on Boeing. But the point is that the findings from air accident investigations are not admissible in a court of law, which is, I think, a very interesting principle.
And do you think that will be extended to robots and car accidents and things like that?
Well, it certainly is not currently extended to car accidents.
Right.
I'm not sure what the situation is in rail accidents, but
and the Rose accident. I was hoping the conversation would lead to this point, actually, because that was going to be the rider question for me.
Yeah, it's very hard to see how, particularly with the intense competition between motor manufacturers.
Yeah.
At the moment they're not sharing anything, and Tesla, have fallen out with the National Transport Safety Board in the US for several reasons. Firstly, they still haven't implemented the recommendations from that 2016 accident, which is shocking. And secondly, they publicly shared some of the data from a more recent accident, and as a consequence were kind of kicked off the accident investigation team, because that was extremely unprofessional. So the point is, I think the culture is going to have to change very radically, really probably in the same way that it had to in the early years of air accident investigation. You may be surprised to hear this, but air accident investigation started in 1915, so more than 100 years ago.
Okay.
But it really didn't become standardized in terms of process and law until the 1930s. And then I think, flight data recorders and such like came in the 1950s. So it takes a long time before you arrive at the kind of culture that and best practice, gold standard, I would say, of air accident investigation.
we've got lots of other questions, so I'll mute.
Right, next one comes from John, going back to risk assessment. He says, does the risk assessment feed into the accident investigation? I.e., if an accident happens, was the risk assessment incomplete or incorrect?
Yeah, I mean, that's again, another very good point. Certainly accident investigators are entitled to ask for any documentary evidence related, in other words, technical documentation for the equipment that is involved in the accident, and that would include risk assessments. So I think it really is that would be at the discretion of the accident investigation team. So really they can call upon almost anything, and they can call upon almost anyone as witnesses, and that might well be anybody from an engineer to to a CEO. In fact, if any of you haven't seen it already, I can strongly recommend the movie with Tom Hanks called Sully, on the amazing waterborne landing in the River Hudson, where of course there was zero injuries, absolutely remarkable. But the movie is terrific because it kind of gives you an inside view. I mean, obviously it's dramatized and so on, of what an air accident investigation looks like. So if you haven't seen that and you're interested, then I'd recommend checking it out.
All right, that's very interesting. It's certainly on a film on my to-view list, as it were.
Well, Tom Hanks is always very watchable anyway. So
that's right.
Yeah.
Yes. Just a comment, I think, here now from Adrian, who says that applies to all three accident investigation branches. The report should not be used to apportion blame, which is what you said.
Mm-hmm.
They're only to improve safety. There's a project looking into the feasibility of a road accident investigation branch. Released, the RAIB released an investigator to work with, he thinks, the RAC.
Well, good. I'm glad to hear that. I mentioned my colleague Carl McRae, and you might be interested that he was one of the key people responsible for setting up the world's first health equipment investigation bureau in the world, and that's in the UK.
Right. We have a question here from Joan. It's fairly long, but if I read it, it's in sort of two parts. She says, thank you for your talk. My question is, there are some accident cases regarding the surgical robots, according to data which was reported by the World Robot Conference in 2021. But the robots are still going to assist human doctors, nurses, and professional carers for the aging society or medical division accordingly. As when we design such robots, we also consider how the pros can outweigh the cons in some extreme moments. Extreme environmental problems like flooding cause a blackout or the other airborne pandemics, etc. How and when can we pass the debates and dispute moments to reach the win-win goals regarding humans by using poor tools, assisting social robots to make our social good in practice? I hope I've captured most of that.
Yeah, in fact, I can read it as well. So I've got the chat window open, and yeah, it's a good question, Joan. And I'm going to have to think about that. I mean, the first thing I'd say is that a very important part of responsible robotics is engaging all of the stakeholders in the design of the robot from the very beginning. In fact, even before you start to write any code or bend any metal, the important thing is that the stakeholders. So if it's a medical robot, a robot designed to be used in a hospital, then you should be talking to clinicians, to to hospital porters, to nurses, to everybody involved, in using the robot. If it's a robot, an assisted living robot, you should be engaging, not only elderly people who might be users of the robot, but managers of care homes and hospitals and such like. So it's really, and wider societies. Well, the point is that we are all stakeholders in this new wave of social robots, this second wave of social robots, and I think we all should have a say. So a very important part of responsible design, responsible robotics, is engaging all of the right people to have those debates, to quite literally weigh up the pros and cons. And I think an important feature of this stakeholder engagement is that it should be entirely appropriate for the stakeholders to actually say, you know what, we think this is a bad idea. And a manufacturer should accept that judgment and say, okay, fair enough. I mean, imagine if such engagement, stakeholder engagement had gone on at the beginning of some of the big AI systems that are currently in the news a lot. They wouldn't have perhaps caused many of the societal problems that we're seeing. So I think I hope that's an adequate answer.
I see one of the, I don't know whether it actually impinges on what you're looking at, but I guess the purpose of the accident investigation is to understand what happened rather than why it happened. Because
both of those things.
I think a lot of the AI algorithms tend to be fairly opaque in the sense that you don't really know why it made the decision it did.
That's right.
And is that going to be a problem going forward?
Yeah, it is a problem already. And there's a kind of a big group of academics working on very, how can I say, sophisticated ways of inferring or discovering why a neural network, because that's what we're talking about. We're talking about deep learning systems based on artificial neural networks. And I'm very familiar with these. I worked on ANN systems some years ago. And yes, they are opaque, as you say. But it is possible to discover, what the particular problem is. And there's a whole kind of literature of explainability. It's sometimes called XAI, explainable AI. And methods are being developed to, as it were, figure out, even without peering inside the neural network, what might be essentially what is the problem with the training data, because that's really what we're talking about. So, I would say that if a robot has an artificial neural network in it, then the accident investigation team should have access to the training data. They should be able to inspect the training data and the provenance, if you like, of the training data. In other words, they should be able to ask questions like, where did you get the training data from? Was it scraped from the internet, or did you curate it? I mean, and if you did curate it, which you should have done, how did you curate it? How did you verify that the training data was sufficient? So, and I'd also argue, and in fact, this is written into the P7001 standard, that event data recorders, or ethical black boxes, as we call them, should be able to store a snapshot of the weights, in other words, the connection strengths of the neural network periodically, that's only necessary, of course, if the neural network is learning in real time online. Actually, we tend not to do that. I mean, it's extremely dangerous to do that. So actually, I'd advise against using neural networks at all in safety critical systems. So, that's one of the reasons that I'm very wary of autopilots, car autopilots that are based on neural network technology. I think it's a fundamental error to use neural networks. But if you do, and I could see a case for neural networks in robots that are somewhat less dangerous than cars. A ton and a half of electric vehicle. They're heavy vehicles, as you know, are pretty dangerous. So at speed. So if we are going to use neural networks, there are ways that we can capture as it were, the state of the neural network at the time of the accident, and then we can do some forensics on that afterwards. In fact, I think that there needs to be, as well as a new kind of community of professional robot and AI accident investigators, there needs to be a kind of new discipline of AI forensics. To be able to do this kind of thing, to really unpeel the layers of the control system, and in particular ones that have neural networks. Of course, algorithmic control systems are very transparent. It's easy to make them transparent, and that's why I would advocate right now only to use algorithmic, good old-fashioned AI, in other words, systems in safety. And of course, it's no surprise that there are no neural networks whatsoever in aircraft control systems, in train control systems, or any critical infrastructure control systems. And that's right. It's right that should be the case.
Yeah. Thank you. Well, we seem to have dried up the questions. Has anyone else got any more questions before we pull this to a close? Mario says, a very inspiring talk.
Thank you.
Many thanks. So there's lots of thanks and the like. I'll add my thanks. It was an absolutely stimulating talk, and your enthusiasm for the subject is palpable. So thank you once again for a superb talk, and I'm sure we'll be asking you back again as we have done in the past.
Thank you. Yes. So well, thank you so much for being such a great audience and wonderful questions.
Thank you very much, Alan.
Do please email me or connect on Twitter or LinkedIn, whichever of those you're interested in, with me. Very happy to answer questions. Also, I have a blog which has a lot of stuff. Much of this work I blog about. I've not blogged recently, for pandemic reasons and health and such like, but basically I'm typing the blog address here. It's just alanwinfield.blogspot.com. So do get in touch if there's anything you'd like to explore further with me. So it's been a pleasure speaking with you. So thank you very much indeed for listening, and hope to see you again soon.
Thank you very much. Well, unfortunately, in these sort of virtual events, we've never been very successful with opening the mic up for everyone to clap. So I will do a token clap. Thank you very much, Alan.
Thank you very much indeed. Yes, I can see some clap icons, which are very, very welcome. Thank you.
Yes, yeah, absolutely. Thank you again.
Take care then. Lovely to see you all. Bye-bye. Bye-bye.
Bye. Thank you.